Okay, can everyone hear me all right? Thanks everyone for coming along today. So it's a pretty casual session and we encourage a bit of interaction. We do have a lot to get through. If you have a question at any stage that you think there's a lot of value to ask that question at the time, please go ahead. Otherwise we might leave it to the end of the presentation. Now if you have a question, just put your hand up, because what we'll do is we'll come around with a microphone. All this gets recorded, so don't be shy. Okay, so look, I think we've probably got the amount of people we have. We'll kick off with a presentation first. I'll make it fairly quick because, as I said, we have a fair bit to go through. So Nova Systems, so 17th Australian Space Forum, and this is the application of digital engineering to space mission design and operations. So first, I have to put on my smart glasses. First, I'll do the acknowledgement of country. So Nova Systems respectfully acknowledges the traditional custodians of the land and waters in which we live and work, and we pay our respects to elders past, present and emerging. Nova Systems also acknowledges the services of the Aboriginal and Torres Strait Islanders men and women who have contributed to defending Australia and its national interest. So I'll just go through some quick introductions. So I'm Phil Krix, I'm the Portfolio Manager for Space in Nova Systems. The areas that fall under my portfolio are space mission design, space domain awareness, and the Nova Space Precinct, sorry, tongue's a bit too long there, which covers hosting ground stations as service, and also hosts our passive array radar system out at Peterborough in South Australia. Okay, my other two colleagues who are the experts at driving STK, Lehi Lynch is here, graduate aerospace engineer at Nova Systems, and Jeet, Shah, graduate engineer once again at Nova Systems. Is Jeet here? There he is. Come on, Jeet, put your hand up. Okay, I'm going to work through quickly, as I said, on this. So I'll let you have a look at the slide. This is the generic slide about Nova Systems. The key points I like to raise: formed in 2000, we're 100% Australian owned and control engineering services and technology solutions company. The other key point is our vision is to be an Australian prime. So a prime by nature needs partnerships, collaborations, etc. So we're keen to work with other Australian companies, also international, big or small. So there's just a chart there to give you an idea of the size. So 1,100 people at the moment, 400 million contribution to the economy, 22 defence partners, etc. And also veteran owned and operated. So I'll just very quickly read over this. So we're talking about digital engineering offers a route to maximise the chances of, efficiently maximise chances of mission success through supported mission design, evaluation, planning operations and sustaining missions. The team will work through an example of an STK, an example of mission design using the STK tool, just demonstrate the value, show the de-risking nature and the efficiency that digital engineering can bring and what is regarded as iterative and recursive process. So I'll just give you a little bit of background about STK. Has anyone here has used STK or knows of STK? Okay, so that's great. I'm not sure if you're extensive users or not. So STK, it's an ANSYS product now. It was originally developed under AGI, Analytical Graphics Incorporated. Started off as really a tool for modelling the satellite side of space. But then actually it involved, well, the application was there not just in the space side, all the algorithms, etc., could be applied to land, sea and air, and it changed its name from Satellite Toolkit to System Toolkit in recognition of that back in 2020. So at the core of STK is really the geometry engine. So it's making the point that it's the mathematics behind there, but it's got quality graphics as well. It's not a graphics machine that has the math. It's math and graphics they're supporting. So Nova Systems uses STK in a lot of other functions apart from the space system analysis. For example, we use it for EW, electronic warfare analysis, for example, complex analysis with phased array type systems, etc. Also in UAV application, mission planning, mission review, etc. Just as some examples. One of the key things about STK is it has an open architecture. So it's very easy to import, export data. So quite often we use STK in combinations with other tools or external analysis tools. That means that we can use STK and cover off more capabilities than comes out of the box with STK. So we use it and we support mission design, trade studies, mission operations, and review and sustainability side. So one of the other great things about STK is that you can rapidly build up a scenario because there's some very simple models that are available to kick off your analysis, and then you can work in further fidelity and further detail to make a more complex scenario. So I also mentioned that Nova Systems is actually an Australian reseller for Ansys products, which includes STK. We also provide tech support, professional services around, as well as training. So just to go over the plan for this session. So we're going to work through an example of mission design process based on a Kennedy-like satellite. So basically a CubeSat with an EO payload. It'll have UHF telemetry and command and an S-band downlink to bring data from the payload. So we're not here to teach you how to become an STK user, but we will show you some of the interactions so you can understand what it takes to operate a tool like this. And in some ways you'll see that a lot of it can be quite simple to use and to kick off in terms of the mission modelling side of it. In the modelling session we'll go over orbits, satellite models, communications, covering antennas, transmitters, receivers and link budgets, access between objects, coverage analysis, reports and graphic outputs, the analyzer function which supports trade studies, look at solar power, thermal, radiation and conjunction analysis dealing with the satellites. Any questions so far? Okay, so what we'll do now is we'll move on to the team here. We'll actually fire up STK. We've got already a pre-built scenario, but we will show you some of the interactions to build up some of those elements. So Lehi and Jeet, I'll leave it to you. As I said, if you have any questions, just let me know, put your hand up, I'll pass the mic to you so we can capture it on the recording.
Hello everyone, thank you so much for coming today.
So one of the other things I'll mention is we would have liked to have had our hardcore space engineers here. Unfortunately, they're either over in Perth at the moment or travelling to support the PDR event for our lunar rover session that will happen with the Australian Space Agency and NASA. We're part of the AROSE consortium in the Stage 1 grant. Okay, great, Lehi. Well, look, I'll get the two of you to maybe go through and give a quick introduction to the GUI.
Yeah, sweet. So STK is really easy to use. I guess to start off with, over here we've got something called an object browser, which is just where all of the objects that you put into STK in the scenario live. And I like to be a bit organized, so I've sorted them into folders of things, like some coverage and some satellites, etc. To insert a new object is really easy. I just click on this insert object tool button, and then there's a whole range of objects and attachments that I can put in with a whole bunch of different configurations or ways of putting them in. For example, all these different ways of putting in a satellite. There's a whole bunch of different views that you can go to, which make it really quick and easy to get around. And you quickly zoom to objects to see them and see things from their point of view as well. Yeah. Anything else? Oh, yeah. And then also one of the great things about STK is how you can view everything instantly. So this is called a timeline view, so I can see the entire period of my analysis, which for this scenario we've built it to cover 10 days. And I can quickly just transport to any period of time there and see what's happening at that point.
And so we can also go in the future or in the past. So if you wanted to look at, I don't know, a space shuttle launch, or you want to go in the future and look at what's going to happen 20 years from now, it will actually put in the sun and all the planets in that orbit as what it would happen in the future or in the past. So you can control the scenario in that terms. So you can analyze your satellites and stuff if you're looking at it in the future or in the past.
I might get you now to just give some examples of orbits to populate those. If we could do a Leo orbit, let's do sun synchronous orbit, a geo orbit, and Molnier orbit as well.
Absolutely. So let's put in a satellite. We're going to use our orbit wizard.
So this is sort of showing you the simple ways that you can quickly start off a scenario.
Oh, sorry, my mouse is unresponsive.
Yes, I should add that we're trying to see the big screen because we don't have anything on our screen, so apologies for the delays in that.
So here's is it Molnier? It starts off with just a whole bunch of basic settings preloaded, but obviously we can adjust these to however we want so that our Molnier satellite acts according to the way that we want. And let's just make it a nice pretty color that we can see very easily. And you can see in a 2D cutout how that orbit is going to look. So if we were to create that really quickly, then here it is. We can zoom to that. It's just a basic model that's been put in straight away. And if we zoom out really quick, then we can see that orbit there. That's clear. So the eccentricity gets, the altitude gets very small over this side, and then it gets obviously a lot larger over here, that eccentricity. Let's put in another one, different kind of orbit. So this one, maybe a sun synchronous, and same thing, right? These settings are preloaded, and we can adjust as needed very simply. Maybe is that geosynchronous? Yeah, cool, thank you. Sorry, I can't read it very well. I'm going from memory of the of the layout.
Just right here with your remote mouse.
Maybe, yeah.
Have a seat. Yeah,
Oh yeah, that works a lot better. Cool. Okay, yeah. So we've got a geosynchronous satellite here. Yeah, white is fine. Cool. So if we create that, then that'll be our satellite 2 because I didn't name them, and obviously you would go ahead and name them uniquely so that you know what you're talking about or what you're looking at. And we can see the geosynchronous orbit there. So very quick, very easy, very simple to do, right?
So just also there's other options as well. So we can very simply choose those models. We can also, for example, load from the SDK data federate, which will draw TLEs. So for objects existing in space, we can do that as well.
Correct. So SDK has their standard object database, which you can load from the web. Or they've also got satellites that you can load from a TLE file. Sorry, I'm trying to move the mouse. Oh, almost there. Oh. Apologies. Yeah, maybe. Oh, damn it.
So apologies for this. We have a setup that you don't normally use, so we can't, to duplicate the screens, we can't record the session. So that's why we're doing a bit of a workaround here.
Yeah. So this one uses the internet to load. Comes up with this screen here, and then we just do a quick search. So maybe like Spirit.
Let's see if we Spirit.
Yeah, cool. So I think we can see our data source here. What does that say?
Operational. So that's the AGI database. So
Local data.
Yeah,
Yeah,
local
cool.
data.
So this data that's already saved on the PC as part of the standard SDK install. If it says like AGI database, that it's from the internet. But this one's already loaded. It's really cool. And we can just insert that straight away. I'm just going to load that up.
So if you're not aware of Spirit, Spirit was the first CubeSat or hardware launched into space as a result of ASA funded grant. Okay, and the Spirit platform is produced by Interval, just like the Kenny, soon to be launched Kenny platform. So just really showing you that the choices that you've got. The other things that you can also do, and I'll get you to go to the orbit page on one of those. For example, when we did the Spirit launch, you can take the preemptive state vectors that SpaceX releases for a launch of a CubeSat, and you can enter that into the system and generate your own predicts for satellites. We won't actually go through that, we'll just show you the page. And also after launch, when they give the updated state vectors, you can enter those as well. So we can deal with that. You also have the opportunity, if you can pull down the data, to put in data in real time and use that to do all the further analysis that you'll see here, which might be the state of communications, etc.
Yeah. Sorry, just give us 2 minutes while we try and fix this, and then we should be right and running.
On the two-dimensional view you showed right at the start for the orbits, can you put relative timestamps on that? So if you're doing the operation stuff at the bottom, can you see relative timestamps on the 2D view? I'm asking you, and then they've got the answer, haven't they?
Sorry, I'll have to defer to the experts on that. Sorry, Jeet, can I grab your time? Did you hear that question about seeing the... Sorry, Adi, can I get you to do that again, thanks?
Yeah, just on that two-dimensional view,
Yep.
you had the operation stuff at the bottom. Can you put the relative timestamps on the orbit? So you can see sort of where
you want to
are.
see it as the satellites are moving?
No, I want the satellite relative to where the satellite is now to some extent, or it's moving. It'd be nice to see sort of where it is in half hour's time or an hour's time.
Yeah, so you
just
can. So what we do is we'll just put the timeline view as what time you want to see it, and at that time you'll be able to see where that satellite is in orbit, and then you can kind of manipulate the viewer to see in half an hour where will it be, and in an hour where will it be. So you can do that.
Okay.
You just need to play around with it.
But you have to sort of move the satellite rather than have the timestamps moving with it.
No, so yeah, when you have the 2D graphics window, only the objects move. You won't have timestamps, but you can add labels and stuff to it. So you can manipulate your way around it. So there are options. It won't be as simple as what you're trying to get it to be, but it is possible, yeah.
All right, thank you.
And what we do is, in the timeline view, what we do is we'll just save timestamps that we really like. So, for example, in our scenario, we have the solar panels articulating. So after orbit, you don't have the solar panels come up straight away. You have to wait a few orbits for that to happen. So what we've done is we've just saved the timestamp where the actual solar panels open up. And what we do is we'll just right-click it and actually go to that time. And it'll show you as it happens, and it'll show you the duration of how long it's happening. And you can just save timestamps, and you can just keep going to those. So that's what we do.
Okay, thank you.
So you can move that across to your screen.
Thanks, Adi.
Run it from there if you want. Oh, yeah.
We're on a run now.
Hi, so I'm Stephanie Hodgetts from BAE Systems. So just with that scenario, which things are built into STK and which ones did you make at Nova Systems? Like, what are the models? Are they yours?
So the models that we use, so the Cagnini type model, it's not a full Cagnini model, but we used an SDK demo model. So we used a 6U CubeSat, even though Cagnini is 9U, but we used that and then we built upon that model. So we just used Blender to add our star trackers, our sensors, our antenna patterns, stuff like that. And we removed some of the solar panels because Cagnini doesn't have those. So we've modified on the pre-built models that we had, but we can still make our own models and then import them into SDK. So yeah, in that scenario, what you'll see custom made from us is, I guess, the antenna patterns, which are Cagnini's antenna patterns, and then the model that we've made. And then we've also got some of the solar panel, the cells that we've added, they're different. They're not generic ones, so stuff like that, which we would show you. But yeah, that's what we've got.
So with the solar panels, is that for like battery management?
Well, it's to see how much solar power is generated, and yeah, just to see how often it's sun pointing, so how much time you're in the sun to actually gather how much energy you do, and then actually figure out how much of the efficiency is actually going into the electronics of everything. Yeah.
Thanks.
No worries.
But essentially, you can use it for power measurement. Okay, and if the detail available in STK is not enough, you can do calculations outside and import those. We're doing something fairly basic here to show you a cross-section. And as I said, there's the standard models, and the next section we go through is just showing you some of the models from the ISS through to CubeSats and known satellites, as well as the fact, as Jeet mentioned, is you can build your own model and bring those in.
I don't think it's going to let us do it because we actually wanted to duplicate 2 and 3. It's just not going to let us do that.
So I'll just talk to some of the up-and-coming things as we're going. So you've seen the orbits there, and you understand that you can use the orbit wizard very quickly, put in certain orbits, set the parameters. We can take TLEs for existing items. We can pull in external state vectors, etc., and build our own predicts on that side. We'll talk about the models. You can see the models. You can manipulate those models, add things on there to make them visually correct, if you wish. Okay, as well as for the calculations such as solar panels. Then we'll move on and we'll actually start populating with sensors, putting a sensor on the spacecraft, okay, which will be an optical sensor, but also showing that you could put things on there like star trackers, etc., and see the field of views. We put a sensor on one of the ground station sites because we can also have articulations with the sensor. So we could, for example, have a file that dries them. For example, if you're doing let's say a synthetic aperture radar, you can sweep a sensor across the Earth from the spacecraft. You can also have a sensor, a pointing sensor, and define that object. So we'll have our ground station, which will point at the satellite with a high gain tracking antennas, which of course by nature of high gain have a narrow beam. Okay, and as well as with that, we'll add transmitters and receivers, define those, show you the simple transmitter and receiver formats as well as the more complex, and we can do a link budget as well. Okay, we can download that data. We can also put the 3Ds, on the 3D screen, we can also display the link budget parameters in real time. Okay, and some of the things that are done also with the real time will cover things such as Doppler shift in the orbit, carrier to noise. It'll take into account antenna gain patterns, so if you're off pointing on the antenna, we'll take that into account into the equations. And also the basic things such as access. When does object A see object B? How are we going, Lehi, and that?
Am I going to work?
Getting there?
No luck with getting it the way we wanted to, but we'll make it work. Okay, what are we up to?
Okay, so we've just done orbits. Were there any further questions about orbits? What I might get you to do is just quickly flash up the models that we were talking about,
yep.
those options.
So, what we'll show
So show a few options and then maybe show and explain what we did with the SSO LEO satellite.
Okay, conveniently not there. So that's our model that we preloaded and we created. So what you'll see is when we articulate it, so let me just run it. Okay. So what I'll show you is how we've imported our model and what articulations we can put on it. So at certain times, like I mentioned, we can tell the solar panels to actually come up and come down. And if we had any other targeting sensors or anything else that was moving within the scenario, then we could show that as well. Sorry, that just turned off. But yeah, so what I can show you, So let me turn everything else off. All right, there we go. Some more space. So we have the model, and what you'll see is if we view some of the articulations, we can tell the solar panels to come up, as you'll see the one on the left come up. And what we'd added is some of the sensors. So that's one star tracker, that's a second star tracker, that's our S-band antenna patch. And if I open the second one, we have nothing on this side. So, and that's our EOIR sensor. So those are the things we added and we configured in-house based on the properties of the Canyoni satellite. Cool. What else did you want to see, Phil?
Do you want to just flick through some of the generic models on those earlier orbits we created?
Let me show you guys that. So what we'll just add a generic model and we can show you. We'll use orbit. Yeah. So we'll just add a generic circular model, and what I'll do is we'll go through some of those models that they have. So currently, the model that we would have seen is this one. Some of the other models that they have are...
The IS, the space station?
There should be the space station. Let's find it. Where is it? Up. ISS, there we go. And it's going to be a hell of a lot bigger. But that's what the space station looks like. And the cool thing about SDK is you can manipulate all the 3D models how you want them. So, for example, you'd want to be able to manipulate where the solar panels are actually facing and all that. So we can actually change the positions of them as they orbit around the Earth. And there's also other things like logos and sensors and capsules and pods that the ISS actually has. Yep.
So what I might get you to do now is let's take a look at sensors.
Yep.
Okay, let's go to our SSO, talk about how we put a sensor on there.
Yep.
The electro-optical sensor on that, and attached it to the model.
Yep. So...
So basically, any object we have, we can apply a sensor and we can define that sensor. Anything ranging from simple conical type sensor through to a rectangular sensor, also antennas as well as importing externally built up models of sensors.
So I'll just show you this sensor. So what you currently see is just a EO sensor, and the properties of it are, we've set it to just a normal EO rectangular sensor, which has a vertical half angle of 22, which means that the vertical angle is 45 degrees, and this is what it sees. And it has a horizontal half angle of 12 degrees, so that's 25 degrees across as well. And then what we can do is we can change them to conic sensors. So if I apply a conic sensor, what you'll see is it's just a 90-degree flat plate with a conic underneath it. And then what else we can do is we can change it to an EOIR, which we'll show you later in the scenario. And this is just a simple conic that we can add to it. And then what we can do is change the location of the sensor. So if you have a model which is a lot bigger and you want to actually physically change the location of where that sensor actually sits, because it doesn't make sense with your CubeSat, what we can do is we can change that. So if I change it to fixed, I can move it, let's say we'll move it 1 meter down. Oh, and obviously it doesn't like me. There we go. Oh, and it moved it up. So I changed that to positive. And clearly it's way too big. So these are some of the things that we can do. So sometimes they are for just visual reasons. So this would just be a visual reason to do that. But there are times when you want to actually configure them to sit somewhere else, as they probably make sense to do so. And then other things we can do is we can make them point at certain areas. So if we had a target in the ground, or we're tracking another CubeSat or an airplane or a ground station or a ground facility, we can have them target that.
Maybe just go to the ground station and look at the sensor which the antennas are loaded on.
Yep. Let's go there. Is it closed again? Just bear with me for a second.
But as Jeet was saying, one of the cool things about the sensors, and maybe a reason why you might want to change where they are, other than just a visual aspect, is because you can actually put an as-el mask attached to the sensor, meaning that, like for example, if you've got one on an AWD, there's a whole bunch of different parts and components and technical aspects to that which are going to get in the way of the sensor. So you can actually change the sensor to consider all of those things so that you have a proper field of a proper way to calculate that field of view and what's actually going to be seen within that. It all gets adjusted based on the objects that are in the way. So that's pretty valuable.
And also, with the satellite example, you want to have the sensor look at the location where you had your sensor in reality, so you can, let's say, determine the effects, or look at the differences from where you might be doing ground pointing for, let's say, an S-band, a high data rate link, compared to acquisition of acquisition on an area on the Earth.
So here we have the antenna pattern that I think Phil mentioned earlier. So
what we see there, it's showing, so we've got antenna patterns there, and they're heat maps related to antennas. That's actually 2 antennas. The broad one, I'll get you to switch off the S-band, please.
No worries. Oh, sorry, I turned off. Yep.
So that's represents a helical antenna. It's UHF, not very high gain, a broad beam. And that will actually point at the spacecraft during the acquisition times. If it was stationary, it was also do the analysis or link budget based on the gain changes you move across the beam there. So I'll get you to switch that off and just put the S-band. So this is a standard model, represents a parabolic antenna. And if anyone here knows their antenna theory, you can see the side lobes that are generated on that antenna as well. So they're the imperfections. Normally, if it was perfect world, it would be a thin pencil beam, but in fact, the antenna generates these side lobes as such. And you can change the heat map. Okay, red there represents the highest gain portion of the beam, which I think is quite intuitive.
So it's currently communicating with the satellite that we had created. So if you look, that pink line is connected to that ground station that we were talking about, and that's where it's communicating to. And you can probably tell that it probably can't communicate to the S-band because it's completely pointing in a different direction, but the UHF, because it's an omnidirectional antenna, that won't be affected by that. So we would be able to see that at the moment, our S-band, our data link budget is showing a very low communication rate because it's pointing in a completely different direction. So what I can do is show you. So if we go into, was it 3 here? The link budget. Access between. Yeah. So I'll just show you a link budget that we currently have with the, let's say, the antenna from here.
What I might do first, Jeet, so we've got the antenna there. I'll just get you to select one of those antenna pages, and we'll just look at the base properties.
Okay.
Just to show the sample model we have there.
Yep.
So you can select a model there. Just go and show the different options we have there. Don't change it, but we have different antenna patterns, which are base models within SDK. Once again, we can create our own antenna patterns from a modelling tool, or we can take measurements from antenna tests on a range and put those in, so real antenna parameters. I'll just get you to close that off.
Yep. No worries.
Okay, and you see there we can do very simple setups. We can set the diameter. It will calculate the gain. It gives you various options, the efficiencies, etc., and the frequency of operation.
And you can change the orientation, like we mentioned. If there's refraction active, is there a delay in that? And then obviously there's the visual side of it that you can see, so the actual antenna gain pattern. And then we can add constraints. So if there's certain times where you don't want the antenna to be active for various reasons, you can turn them off. Another key aspect is you can add environment models. If you're going to face losses from environments or atmosphere, you can add those models. You can input your own models into that. So it'll predict how much of a signal to noise ratio is increasing or decreasing as per the environment models that you've added.
And just look, I'll just get you to put the slider down there at the UHF ground station. You'll see that they're basically a child object, the two antennas, to the sensor. So the way we do a tracking antenna is we have an antenna model. We'll actually apply a sensor in there, and we make the sensor pointing, and we can select that pointing to an object. Do you want to just click on that sensor there, and we'll have a look at the pointing selection.
So like we mentioned earlier, you can target the sensors. So what we've done is we've essentially created a servo out of a sensor object. And what it's currently doing is whenever the SSO LEO, which is our CubeSat, the Canyini, when it comes across the horizon and you can actually get line of sight access to it, it'll communicate with it. And then obviously that access isn't communicating with it, it's the antennas that are actually communicating with it. So through that, we can see the link budget off that.
And those antennas are configured to connect to the receivers and transmitters that we've set up on the ground station and also on the satellite.
So these two antennas, the S-band and the UHF that I've selected, communicate to the S-band antenna and the UHF.
Sorry, got a question over here. Here you go, Adi.
Thanks, Phil. I'm not sure, you probably haven't done it, but I'm not sure you may have done. Have you validated their link budgets against what you're actually seeing at Peterborough and things like that? I mean, how accurate is this model in terms of using it for developing your requirements and things?
Let's just say we haven't validated against Peterborough, not with the Spirit antenna there, but the link budgets are sound, so we put in our own parameters. So if you get everything right, you put it in correctly, okay, then it will be correct. But there are some assumptions in the simple link budgets in terms of the performance of codecs and things like that, but it's pretty close, okay? And you have the option to tweak it to actually validate it.
And it also depends how much fidelity you want. So how much fidelity you give it is how much you'll get back. So if you, for example, don't put any environment models or atmospheric loss models, you're not going to get any of that. So you don't know how much you're going to lose based on that model being active or not active. So a lot of it is just the more data you have to feed it, and then you'll get the results you want. Because, for example, right now, what we have is a very basic model. We've put some parameters, but there's no models, there's no loss that's in this. So we would be getting theoretical maximum gain values. So if you're asking how accurate is this, not very, because we haven't put in everything we want to. But if you have all that data, then if you put it in, then you'll increase accuracy. And obviously, it's a model. It's not always going to be 100% correct. You're always going to have losses and things like that.
So what I was thinking about doing now, Jeet, so we kind of spoke a little bit about populating the satellite. So we've taken the satellite, we've put a model on there, we've got solar panels, we've added antennas, and also with the corresponding ground station, the antenna patterns, we put transmitters and receivers in there. First, I just want to show some of the access. If you could just show a pure line of sight access from the ground station to the satellite, and then after that, we'll move to an access which we'll use to then display the link budget.
So ground station to satellite, access, we can really quickly compute that. An easy way to find your accesses is to go into an access report, and this shows us all the times when there is access between the satellite and the ground station, and it shows for how long they've maintained that access as well. So then I can very quickly, let's pick this one. This looks nice and long, and I can set my animation time to that, and now I can go ahead and I can look at that, and I can see very clearly that there is access between this ground station and follow this pink line over to the satellite. So if I slow that down a bit and play that scenario, I can watch them track.
So over on the left there, we have the simple link budget parameters there, and you can see that link isn't working because it's got a negative carrier to noise. And also on the right there, we've got the ASL at the ground station.
Can I define that access period based off link budget settings? So obviously we have our field of view of when the target comes into sight. I might have a set link budget parameters that I can look at that. Can we define it through that way as well and get reports that way easily?
Yeah, absolutely. So we can put in those constraints. I think Jeet showed a little bit earlier how to define some constraints. And for example, if I want to have a particular particular level of BER for it to be considered active or viable, then I can put that constraint in as well. So it'll remove all of those other accesses that don't meet that constraint and only show the ones that are valid for it.
I wish I'd known that when I played with this. When I played with this software last.
So you can add time constraints, you can add quality constraint, you can say, I want a carrier to noise ratio of above 10, and if it never goes above 10, don't ever show me any results, and you can add those parameters. So something else that we would play with is if we have an EO sensor, we only want it to work when the sun's out, because obviously it's not going to see anything when it's on the dark side, so we can add those constraints as well. So yeah, it's quite simple to do so.
Some of the common link budget constraints we do is at the earth station, so we define, depending on the frequency coordination, it might be 10 degrees minimum elevation on that side. Okay, so we've done the link budget side of, sorry,
I'm just showing very quickly just a few of the basic and easy constraints to put in. Sun was one of them. As the satellite is coming up over the horizon, obviously it's transmitting through a lot of the atmosphere in that way, and so there's going to be more interference, more noise, so maybe we want to restrict when that access starts, maybe like a 10 degree elevation before we start considering it valid data, so we can put in the sun elevation angle or even just an elevation angle before we actually want to see the results.
Could I get you to go back to the 3D graphics? I just want to see which, just down the screen. Okay, as well. So you see up there, it's also doing the Doppler calculation as well. So we'll take that into account. If you look at the receive frequency, originally it was set the center frequency to 2.3, but it's showing the Doppler. So when we do a receiver, normally we can do inherit from the transmitter. So it automatically goes to that frequency, but tells you what your Doppler is, which can be useful if you're in a stage where you don't have a very well-defined TLE, and you can just look for when center frequency occurs at maximum elevation. So that can be helpful in selecting what's the correct TLE in the early days of acquisition. So what I might also do, so maybe let's do a very quick access from the optical sensor to the ground station, and then I'll get you to move on to the coverage. So it's really easy with the models in this, it's really easy to see when something can see something, but there's also the capability to do, let's say, linked or chained type arrangement, which could be a UAV sees a boat, UAV sees the satellite, and the satellite sees the ground station. You can do complex link calculations like that as well.
So what I did was activate the EO sensor that we had already created earlier, and then I just created an access between that sensor and the ground station, and then I looked at the report to see when that happens, and I've just set that as my animation time so I can actually see what's happening there.
Lehi, could I get you to do that bit with the spacecraft with the sensor at Nadir?
Yes.
Because I think we've inherited that selection to point at the ground station.
Yeah.
So let's do something more realistic.
So I think that one is slightly more complex, although not difficult, I must note. So what we've done to do all of these different pointing modes is to create a multi-segment attitude list, where for our first 2 orbits, we've said that we want the satellite to be spinning, and it's also trying to track the sun vector, so it's spinning, but also trying to point its solar panels towards the sun. And then it's going to go and just do a straight sun-pointing orbit where it folds out its solar panels and then points those solar panels to the sun. Then we're going to point to the ground station, as we just showed, and then we're going to point to Earth, so the nadir type. And what we can do here is just copy this time, paste it in, and let's go have a look at what that looks like. So if we go to the satellite, we can now see that that's what it's doing, and we'll play that a little bit. And we can see that, right? It's pointing straight to the middle of the Earth.
So can we do an access to the ground station just based on that pointing?
Mm-hmm.
So through all these different attitude changes, you can of course be running all the link budgets. So you could see the effect of, say, sun pointing in terms of ground station access, which with a wide beam of UHF is not a problem, but can be, will absolutely be a problem in most circumstances for S-band. So you can do a whole series of let's say, link budgets or other calculations changing certain parameters as well, which means you can go through and, in a way, do various trade analysis or trade studies. But after this, we'll work through something a little bit more complicated than access, which is talking about coverage, which is particularly applicable to Earth observation sensors. And then we'll actually go and use the analyzer tool.
Cool. So here it is. So we've got that access between the ground station and the satellite, but it's also got its EO sensor pointing down towards the centre of the Earth.
Yeah, so can we have a look from the EO sensor to the ground station? Just run an access report and see when that happens.
Yeah, this is our access times. Mm-hmm.
And you can see that now the EO sensor is looking at the ground station that we have. That might be the Sydney one.
This one.
Yep. And there you go.
We're moving to coverage now, Phil? Question? Yeah.
It's a simple question. Is that based on the satellite body pointing, or is that the EO sensor pointing in a particular direction?
So the way it counts it is that the sensor has a field of view, and the ground facility has a point of origin. It has the facility display, as we showed earlier.
So is it based on the satellite's orbit, and like you had pointing at the sun, skew, and Earth? So this is the Earth orbit one. So the satellite's kind of nadir facing at this point.
Correct. Yeah.
I think in that option, you may have selected a time there where it's actually pointing to the ground station, because it doesn't look like it's pointing nadir.
Oh, that's true.
Yeah.
Sorry.
But you can do that. You can set it to nadir and then look at the access times.
Yeah. So what happened was in the way that we set this up, while it's pointing nadir, it doesn't actually go over the ground station, and therefore we don't have any access during that time. Phil threw his curveball. So I just picked the next closest time, because that time when it was doing nadir was about 1900 hours, and now we're looking at 2300, so a few hours later on. So now we're doing something else, and it's during this something else when we get that access for the EO sensor to the ground facility.
But you can consider both.
Yeah.
Okay.
So if I define it as such, then I can do what you're asking, but I didn't define it as such already.
Yeah. So I suppose it's more about when you think of body pointing, is it trying to make the bore sighting more consistent for that EO sensor at that particular time? So it's looking at a certain target. It's probably the question.
Yeah. So the way that we've modelled the Canigini-like satellite is that it doesn't have any like servo motors on board to be able to point the EO sensor.
Yep.
So it has to point its whole body. So it's only at those times when the whole body is facing the sensor to that facility
thank you.
that it can do that.
Yep.
But you could lock the spacecraft pointing at nadir with that sensor and then do the coverage, the access.
Are you able to view the satellite telemetry during this as well, if you wanted to see what the GPS or the attitude on board the satellite would be?
Yep, you can. So right the satellite. I'm just going to report.
I guess it's not the telemetry as such, but you can put up on the screen there the attitude.
Attitude.
Yeah.
Attitude segment. Okay, so that just shows what the satellite was doing. So try quit. So that actually gives you what the satellite is doing. It's just in a different format. So if you wanted it in, let's say, in the body axis, you wanted to see what rotations it was performing in that axis, we can change that. So this is just a default report that SDK recommends you can use. So what we would do in that instance is we'd customize a report and say that I want to see what the satellite is doing, what is its position, and what rotations is it performing. But in this instance, you just got it in a different format.
You're basically a different reference.
Yeah. So
what I might do is I might get you to go onto coverage, just explain the coverage side of it. This is particularly useful for the Earth observation sensor. And just to confirm that for this, when we do the coverage, that we're set with the Earth optical sensor pointing to the Earth, nadir, not pointing towards a ground station or anything else.
Correct. Okay. So we've created some coverage previously because it can take some time to set up properly and just to get all the computations done. So here you can see, let me just turn this off, sorry.
Just, Lehi, just maybe a little bit back and just explain the figure of merits and the intention of the setup.
Yeah. So what we do first of all is create a coverage definition, and we define what our coverage area is, how we want to analyze it. We define the asset that will be of interest. So anytime that this particular asset interacts with our coverage area is when we'll receive a tick to say, it's valid. And then we run a computation on that, and then we insert a figure of merit. So what that means is that we can now define what information we want to get out of that computation. And SDK is pretty cool in that it computes everything and then lets you select what you want to see. So for our figure of merits, what we've done for this first one is say that I want to see how many accesses occur over this 10-day period. And one quick second. What we've done is create this legend to show how many accesses there are, and then this graph obviously is the one that shows the data visually. So we can see that there's a few areas that have no access during this 10-day period, but then there's also a few areas that have a lot of access, like 12 to 14 accesses over these 10 days, which obviously is going to be very, very useful, very interesting for us, and then variance in between.
And that's the coverage area defined as the Australian mainland, and the asset, of course, is the Earth optical sensor. And so you can define different areas there. And this is important. I think if you're interested in a particular location over a period of time, let's say there's a bushfire or something happening, and you want to go, okay, what's my access in the next 5 days? How often am I going to see it? Am I going to see it?
Here's some South Australia accesses, showing very similar things to what we saw in the whole of Australia. And then also we computed some revisit times. So how long does it take for the satellite to come back to this area? And this is done in a unit of days. So in these areas on the outside of the South Australia, it comes back within 1 day, less than 1 day. And then towards the right-hand side at the top, it can be more than 10 days before it comes back.
And I guess this is illustrated that you're a prisoner of the orbit when you have a satellite. And that's all dependent, of course, on the sensor swath, etc., and the orbit. What I was thinking now, let's go and have a look at the analyzer function. So whilst you can do trade studies and go in there and, let's say, perform different scenarios, the analyzer function lets you look at a parameter and select that parameter as the parameter of change, okay, and compare that against your defined figure of merit. So we're just going to give you an example here. And this example, we'll be looking at, okay, how do we select, let's say, the best inclination of a satellite to give it defined coverage?
Okay.
So we're doing something which is, let's say, a different requirement to what we look at with Earth observations as such, where you're looking at a constant sun angle, but looking at just really coverage in that area, which might be in terms of, let's say, surveillance, and looking at a particular area of interest.
So it didn't save from the last time I did this, so that's maybe on me. But the good thing is I can show you guys how to go through it, because it's quite simple. So what we'll do is we'll set up an area that we're interested in. So what we were doing was we wanted the East China Sea. So what we will set up is a small little coverage area, which you can see on the right there.
It's just a manual drawing, isn't it, Jeet?
Yeah, it's just me basically going, I want something that looks like that, and it'll set up an area target, and we'll call this the East China Sea, and we'll apply that, and cool. So now what we want to do is we want to see when our satellite goes over that coverage area, how many times it goes over it, what's the revisit time. So what we would do in this instance is we've set up our area target, now we need to set up the coverage of it. So I'll set up the coverage properties to say that instead of a global coverage, which it's currently showing, we'll set up our region of interest, and our region of interest will be the East China Sea. And we'll apply that, and what you'll see is everything disappeared, and now it's put up a coverage of the East China Sea. And obviously you can probably tell that those points are really far apart, and that probably doesn't give us the fidelity we want. So it's currently at a 6-degree granularity. We don't really care about that. I'm just going to set it to, let's say, 100 kilometers apart. And what that'll do is it'll populate that custom region with points 100 kilometers apart. And obviously if you wanted more fidelity, you can add that, but that will also increase the amount of time it takes to actually compute all of this. So it's a trade-off. And now what we'll do is we've told it what our coverage region is, but now we need to tell it what's actually looking at it. So if you guys remember, our CubeSat was the SSO LEO, and we want the VNIR sensor to look at it. So that's just the electro-optic sensor. And what we'll do is we'll assign that and apply that. And what it will do is, as we mentioned, the CubeSat has multiple different orbits. So what it will do is it will take into account when that sensor is actually pointing at that ground at that specific point in time, and calculate the coverage based on that. So what we'll do now is...
Just to confirm, Jeet, that will be with a spacecraft with a sensor pointing at Nadir?
Well, it could be any of the different options, but
yep.
It only looks at the Earth when it's nadir, so it should only be nadir.
Okay, great.
Yep. And we can add that constraint that we only want it to give us the results for that time period when it is on nadir. But in this case, we'll just let it do its thing, and we'll see how it goes. Now what we'll do is we'll set up a figure of merit, which is basically us telling what type of data do we want out of it. And what you can see is that's how much of the area was covered. So what we'll do is, instead of a simple coverage, which it was showing, and a simple coverage is just, does it go over that point at all? But that's too basic of an information. We really don't care. So we'll set it at revisit time, because we want to see how long or how short is the time before it can come back and see that period. What we'll do, if I can press OK.
So it's the classic scenario, something of interest happening in an area. When are we going to see it? What's that revisit time on that area?
And now you can see it's a very bland static color, but that doesn't actually tell us anything, because we haven't actually set any contours or a legend for what we're doing. So our scenario is from 0 to 10 days, and we have a step size of 1 day. So we want to see what happens if we add those constraints. So we'll add those levels. We will add a natural neighbor, and we'll apply. So now we can see some more useful information on what's actually happening. So, sorry, give me 1 second.
So this is setting up the legend. Is that
yep.
right, Jeet?
That is correct. So now we have a better understanding. So now we can see that the red areas, so these areas here, it took 10 days to get back to that area, whereas most of the blue, it's getting there within a day. And obviously there's a bit of red there. So you saw how quickly we were able to set up an area of interest with using the area target. We set up a coverage for it. We assigned it the CubeSat EO sensor, and we were able to calculate basically anything we want. And obviously this is just a revisit time, so revisit time. If you wanted to see number of accesses, we can add another figure of merit. And what we'll do is we'll say, instead of giving me revisit time, give me number of accesses and give me the total number. And what we'll do is we'll turn that off. And again, we'll go back to the static, we'll show contours, and remove all. And I don't know how many accesses there were, so I'll just put 20 as the maximum limit, and we'll go to a step size of 2, add that. Oh, so we can see that it doesn't really go above 1 or 2. I guess a bit in the middle it does go.
So a relevant scenario like this might be, for example, a bushfire in Australia somewhere, and we go, okay, with Kenny, are we like, what's the opportunity to see it within a defined period?
Okay, that's a little bit better. Sorry, I had the wrong colours showing, and therefore you couldn't tell what was going on. So let me go back and add that legend. So let's show that. Cool. All right, so that now gives us a much better view. So you can see the red and slightly orange. So we're probably only getting accesses on the right and left side once or twice, whereas the center, we're able to get 10 hours, 10 hours or more. 10 accesses or more, sorry.
So now the next thing I'd like to do is if we can use the analyzer.
Yep.
Okay, to select the parameter of an orbit, the inclination parameter.
Yep.
And see the optimum solution.
Let me turn that off. Oh.
Thank you. What if you had multiple satellites, like a swarm? Can you put that into this as well?
Yep.
Amazing.
Yeah. So, is it me? I can't see that. Okay. We'll just create a satellite in front because that also did not save. So tell us what you'd like, Phil. So where'd satellites go? Satellite. Okay. Orbit wizard. What type of satellite would you like?
Let's just start off with SSO parameters, okay, and then we'll vary the inclination of that.
Yep. Where are we? Yeah. Sorry. So.
And Lehi, I believe we can do that, can't we? We're not fixed. We can change that parameter. I think you've done that before.
So we'll just leave all the basic parameters. We don't care about the model. Sorry. Yep. Sorry. Cool. And we'll set the altitude to 400. Where is our nice and pretty satellite? Yep. So there it is. And what we'll now do is we'll tell SDK. We'll give it a set of parameters, and what we'll do is it will tell us for us changing a certain set of parameters, how much access are we able to gain out of it? And what that means is we'll set up an analyzer trade study. And obviously it comes up with an, there we go. Cool. So we have an SSO satellite that we just created. So we're going to try and change the inclination. And what values do we want out of it? So where did our coverage go? So let's say we want to see revisit time, and we want the minimum value, and we'll just chuck in the average values as well. And we'll set up a normal statistical design of experiment study. And all we're telling it is we have an input, which is the inclination of that satellite, and we want to see when we set the values from, let's say, 120 degrees to 180 degrees.
Well, what I was going to suggest, maybe a lower one.
Yeah? What would you like to
let's say the low is, say, 30 degrees.
Sure.
And what's the current SSO inclination? I didn't see it was a 98 or something like that?
Yeah, something like that.
Yeah, and just leave it as 98
okay.
at the high end.
Cool.
And let's run that. Hopefully that's not too computationally demanding.
What I'll do is I'll tell it set 5 levels between 30 and 98. So what that does is it'll divide them up and it'll say 30, 47, 64, 81, 98. And essentially what it'll do is it'll go in, change the satellite's inclination to each of those values, and then return what the revisit time would have been. And if I run this, okay, it's currently being performed. Sorry, give me 1 second. Oh, it closed. It's saying that somebody's already performing this. Okay. All right. We'll set a normal parametric study instead. 30 to 98, and we wanted 5 samples, and we want that. Okay, fine. It's not feeling like it wants to cooperate. So what I'll do is I'll just load up a study that we have set up. So,
for some reason, SDK's got some performance anxiety today.
Open trade.
So when Jeet pressed run before, what should have happened is another window pops up where it shows our input variable and then our 2 output variables, and then it runs through each computation. It's going to do it 5 times, so 5 different levels of analysis, and it's going to go through those automatically really, really quickly. Obviously, the more difficult the computation is, the longer it's going to take, but this was pretty simple, so it actually should have finished by now. But the value in that is that it will do it by itself automatically, as opposed to us having to go into the satellite settings, change the inclination manually, and then generate a report from it, grab the results, and then copy them over somewhere else so we can keep track of them, and then go back into the satellite properties, change the inclination again, generate another report, etc., etc., etc. So we don't have to do all that manually. We can just do it all automatically.
And inclination is just one example of one of the parameters you could play around with. You could also play around with parameters on the link budget as well. You could look at antenna sizes, etc. You could also play with probably the swath width as well on the sensor, if you wanted to have that as the parameter to change.
Yeah, so, sorry, too close to the mic. Yeah, that hasn't seemed to cooperate with us, but what it would essentially do is, like we said, it would show up with a bunch of reports that look something like this. So we'll see the grid stats, and it would essentially tell us what the minimum, maximum, and average time was. So what we would have seen is, for each of those inclination values, what was the lowest amount, like how quickly was the satellite able to come back to that period. And the biggest, I guess, advantage of it is it saves a lot of time. So if I was to go out and do that, it would take me 2 to 3 minutes to do it every single time for all of those iterations, whereas it does it all for you as a trade study.
Okay, great. That's the law of running software live in a presentation. Doesn't always work. What I thought I might do, just had a quick look, and I thought of the time we've got remaining.
Yep.
Might get you to go to do the radiation analysis.
Yep.
And then at the end we'll do the conjunction analysis.
I think I closed your scenario.
Is it running off local compute or off cloud compute or the actual processing?
Local.
Local.
Yeah. So essentially, the beefier your PC, the better everything will run.
A question, and I apologise for the late camera this before, but what variety of missions do you use or problems do you mainly use this tool for, and what problems do you find it best suited for, in the sense like analysis of a constellation of common satellites or satellite conjunction issues or these sorts of surveillance issues? I think.
I'll get this right one day. So normally, I guess the most value, you can use it for very simple calculations. The most value is where you have a lot of variables. Let's say if you're doing multiple satellites, okay. We use it, so I'll just say we use it, you may have missed this earlier, we use it for space, but we also use it in our electronic warfare analysis. Okay, looking at interference, all those type of things, access and coverage on that side, and often we do that with using some antenna modelling tools or doing some complex calculations outside because of the open architecture. When we're doing satellite, this is the sort of typical thing we look at. So even though you've just seen here, we're looking at the analysis on the ground coverage, in the same scenario, we can do all the comms analysis as well. So we can put transmitters, receivers, define antenna patterns as well and do that on the spacecraft. Okay, and if you're looking at if you're starting to get really complicated, you're looking at a constellation and you wanted to model satellite to satellite links, something like Iridium, you can do that as well. Okay, and look at when the satellite can make connectivity as well as the actual link budgets. So anything dynamic, and there's lots of variables, perfect tool. Well, okay, I won't say perfect because I might be biased because we're really a good tool.
Yeah, so Lehi and I are currently modeling drones on this. So this is probably a far reality from what you guys are doing. So we're modeling drones on this at the moment. So it can do a lot of other things. So ground vehicles, comms, maritime stuff. This is just the space stuff that we're going through. But a lot of the key things are once you've modeled the object that you want, a lot of the analysis is all the same. So like the axes, can you actually interact with different objects? How much, like how many accesses can you get? What's the link budget? What's the comms like? So a lot of it becomes very similar across domains. It's just the objects that you're working with. Obviously, space is a very big domain in itself, but we also use it for air stuff. So, yeah.
So what we'll do, oh, sorry. That's all right.
Yep.
One thing I've just been clicking through is basically you've got these tools to show the link budgets, change the signal, simulate the satellite spinning, and error problems. Can you then translate that into simulations and examples of the signal changes in that for representative operators to help train them to understand what happens to the mission aspects?
Oh, definitely. So you could use that, if I'm getting your question right, through the display on there. You could export the data as well. So it can be used for training, and some of the things that it's been used for is, for example, training ground station operators in LEOP. So you can do an accurate model of the satellite, let's say in spinning mode. You can simulate the signals, but you can also do hardware in the loop. So you could inject a signal into a ground station that would show typically what you'd see during a mission. So what I'll do is, because we're running a little bit slow on time, we'll just quickly work through this. And what we're doing here is modelling the South Atlantic anomaly. So South Atlantic anomaly is a result of the Van Allen belts, and particularly the inner Van Allen belts. And just very quickly, okay, the Van Allen belts protect you from radiation, but they also trap high energy particles. Now, because of Van Allen belts, and it's driven by the Earth's magnetic field. The Earth's magnetic field is not aligned with the poles of the Earth. Is that over the South Atlantic area, the inner Van Allen belt, there's two of them, inner and outer, comes very close to the Earth, roughly about 200 kilometres. Okay, that represents an area of high radiation with impacts to spacecraft, people as well. So some of the things might typically happen is you might get a spacecraft goes through there and it might have a change of state. The particles affect the electronics and maybe it switches, it changes configuration on the satellite. It could also permanently damage components, and that can be, happen rapidly, or it can be accumulative over time. So one of the capabilities within SDK is the ability to basically analyse, to project and analyse the Van Allen belts. I'll pass it over to you if you want to talk to just basically what we're showing here.
So really quickly, you may have been watching as I was doing it live. What I've done is model the South Atlantic anomaly. So I've just changed my flux level for the South Atlantic anomaly to be 10th of peak. That's what AGI recommends to model it really quickly. I guess if there's more accurate data that is needed, then you can do that as well. I'm not familiar with it, so I just do what I'm told. And then just really quickly, I just choose to show it or not show it, and I've chosen to show it because we want to see it. And then here it is. So I've done that for both our standard SSO LEO, but then also I put in a really quick Molniya satellite to show a lot more variance, because it seems like the South Atlantic anomaly changes in its influence upon the satellite with respect to altitude from Earth. So we can see that really clearly here. As I play the scenario, you can see that this effect is getting bigger and bigger, until it's gone.
And you can see the satellite is currently right at the bottom of the Earth, if you can point towards it. Yep, right there. So that's where it is, and that's the South Atlantic anomaly based on that.
And the other area represents that constant altitude.
Correct, yeah. So this blue part didn't change at all because that's our SSO LEO, and that has a constant altitude for its orbit.
Can you, I'll just get him to do this and then I'll pass it to you. Can you do the, I think it's the access or the analysis that'll show you the actual levels from the spacecraft? So you could use this for example, some operators actually just automatically configure their spacecraft after it, or sometimes they switch off some systems before going into it. Anyway, I'll pass it to Adi.
So this is a moving satellite, obviously in a static Van Allen belt. Can you ingest data, like a model of the Van Allen belts, because they're very dynamic? If you were going to do a long-term analysis of total radiation, could you actually put in historical data on?
We haven't explored it, but I can't see why not. So we might not do it the way they suggest it, but you can import a different object and say that this value is going to vary from 0 to 100, for example, and tell me what that value will be. So you can add your own calculations. And with that, I would add a varying model of what the Van Allen belt does, if that makes sense. So at the moment...
Yeah, so they just give you altitude and energy of certain particles and not a lot else.
Yeah, but you can add your own models custom. So you can add a script. So I would script this. It would just be easier to script it in. But you could have a model and you could import that in as well. At the moment, it's just a static value, and as altitude changes, it changes.
Yeah, it's just, I wonder if it's probably whether it has the grunt within this modelling environment to take in such a complex model. Would be interesting.
I would say so. So far, we're looking at fairly simple and quick modelling, but normally, as Jeet said, there's the ability to do it, whether it's loading in a model or doing a calculation outside. But I think you would probably be right. It's like, for example, using this for thermal design. We can do some very basic thermal design, but it's not the thermal to you. You do it externally, and if you wanted to import it so you could include that within all the other analysis, you could do that. What I'll get you to do, let's go to conjunction analysis, because that's interesting, and it takes us about 10 minutes to do it. Well, maybe less if you've got it set up and it's all working.
Here's one I prepared earlier.
Oh, okay, fantastic. Did you want to remove the South Atlantic anomaly? Let's just get one problem at a time.
Yeah, I'll turn it off. Done.
We can all just turn off the South Atlantic anomaly.
Right, so what's happened here is that I've used SDK's inbuilt advanced CAT tool. I think that's collision avoidance tool. And so what it does is allows me to define a primary object. So in this instance, my primary object is my SSO LEO satellite, because that's the one that I care about. And my secondary object, or my secondary list of objects, is SDK's all TLE database file. And what I did as well was go through and customize the default settings. So you can see here, defaults, the tangential size of the ellipsoid of
uncertainty, yes,
is 20 kilometers. The cross track is 10 kilometers, and the normal is 5 kilometers, and it's very, very large, very, very uncertain. So just to increase the fidelity of our scenario a little bit, not that it's based on anything that's actually true, just making it smaller, I just cut it all by a tenth. So 2 kilometers tangential, 1 kilometer cross track, and half a kilometer normal. However, our threshold is still 10 kilometers. And what that means is that I'm going to be pinged with a warning when those two ellipsoids of uncertainty are 10 kilometers apart. So then what I can do is go here, and all these green dots that you see on the screen are all of the TLEs, all 27,900 of them that SDK currently has loaded up. And what I really care about is my SSO LEO, right? So I can go here, I can see this ellipsoid of uncertainty. And then the part that I'm interested in, though, is when does that actually show me the collisions? So what I've done is create a custom report. Create the custom report, which will tell me all the different times when that threshold is active, that 10 kilometer threshold, and then it'll tell me a bit more information about that. So this report, we can see here, say, we'll just take this first one. The time that I enter that threshold is shown. The time that I exit it is shown. The time of close approach is also shown. What that means is that I'm at 9:44:50, I'm within the 10 kilometers, but at 9:44:52 is when I'm closest in that collision possibility, and then I exit that 10 kilometer threshold at 9:44:54, right? What we also see is that we have a minimum separation, but in this instance it's actually an intersection of those ellipsoids of uncertainty. However, I can also see that the minimum range between the actual satellites in this instance is still 250 meters away. So we're not actually colliding, and I can see the relative speed there and also the collision probability, which, as we know, probability is between 0 and 1, and this is very, very, very close to 0. So let's go have a look at that. We'll quickly see this first one.
So just jumping there, obviously this is more of an operational tool, and satellite operators are doing this, taking the data from the database maintained by NORAD and other users, and looking at where there might be collisions. Okay, and if there's a collision, it's close enough, it's a concern, they might do things, for example, satellites that don't have propulsion move into a high drag configuration to try and change the orbits. So this is something that you could be running all the time, and we've got the ellipsoids of uncertainty, and obviously that's driven by the accuracy of the data that you have, one of the factors in that. If you, for example, might be tracking by radar, or depending on the source, you want to, account for the fact that it's not going to be perfect. And that also depends on how important your asset is to you as well.
So while the ellipsoids are green right now, it means that I'm without the 10 kilometer threshold. And as I press play, you can see they turn yellow, so now I'm within that 10 kilometer range. And then you'll see them turn red, and that means that those ellipsoids of uncertainty have actually intersected. But again, like we saw in the report, the central point of this satellite and the central point of this other satellite is still 250 meters away. So even though they're very close and those uncertainty ellipsoids do intersect, STK believes that there's not actually going to be a collision.
Can you identify that other object?
Yeah.
Yes. I'd like to think.
Sorry, is orbital decay included in this calculation? And if so, how up to date is the data at the moment?
So we updated the database a few days ago. So what was online on Sellers Track, we've uploaded everything as per that, but I'm not sure about the orbital decay.
I can answer that really. Because we're not connected to the internet, we didn't get the latest, but it depends on what values are in the database that's usually maintained by the US. So things are normally updated fairly regularly on that side. Does that answer your question? Sure.
Just given the rapid increase in the number of satellites up there, in your own experience, do you find yourself doing a lot more conjunction analysis, or do you find it more complicated even in the last few years, let's say, than before?
So for us specifically, because we don't own and operate any satellites, we're not really doing this. Okay, we're aware of it, we train people on it, and we sell and support the tool that does. But those operators like Starlink and AD, you might know, Starlink have propulsion, don't they? Yeah, some of them do. So you hear about, they look at Starlink, and it's not unusual for them to be doing manoeuvres to counter conjunctions.
But that hasn't fed back through to your experience, if you see what I mean.
Oh, okay, I guess I'm not directly tied into that. We know it's happening, and we know that organisations with satellite, particularly constellations or even important satellites, are doing this all the time.
Yeah, but you're not seeing customers suddenly banging on your door wanting a lot more of this, for instance.
Oh, no, because they probably already have those tools.
So the ASA is now looking at their civil space monitoring capability that they could have and should have. So they've grabbed these tools and they're looking at what is. Could they, if they get advised for our regional or for our interested satellites, they can do what is advice to the government authorities that need to make any decisions or to make advice, etc. So they're working out like what's the best level of service that the space agency should take on over and above any commercial service provider to do that risk mitigation advice.
Yeah, I was just trying to get a feel for the rate of change in this area, if you see what I mean, given the growth and the number of objects, whether it was evident to you people.
Well, I guess as BJ mentioned, in terms of the demand, yes. And if you look at Starlink and how many satellites they're putting up and what their ultimate plan is. Sorry, Adi, did you want to add a comment?
NORAD used to do this sort of all on their own, but now they're taking in third-party industry players that are providing information because they can't keep up. They don't have enough stations out there, enough data. So, and like you say, people are doing it privately anyway. You can buy the service now.
But I think we've heard there is from there that's talking about how many alerts they get, like thousands every day, that they're updating constantly about risk alerts and then monitoring them and advising about it. So, yeah, it's full on.
Lehi, was there anything else you wanted to demo on that?
No, sir.
That's cool. Well, we've got 3 minutes if anyone's got some questions. I hope that wasn't too dry. We had a little bit of a slow start because the configuration we were using here to be able to drive the software was not the normal configuration they use there, so it's pretty difficult to start there. And I know it's a very high overview, but hopefully you can see out of that, STK is just a tool, one tool. There are other tools out there, and as I said, we often use STK in combination with other tools, which can give us some more fidelity or external calculations, etc. And that's the great value we find of that, the open architecture that supports that. Yeah, and if anyone ever, here we go.
Thanks. You mentioned earlier there's some scripting capabilities built into this. Can you give like a super quick overview as to what that is?
Yes. So I use the Python API that's built upon this. So it's just whatever you need it. So what it does, it just connects to the GUI, or you can use it to not connect to it as well, but you can control objects and analysis, and you can get reports out of it. It's just an easier way, instead of manually doing everything. The reason I did it was because I didn't want to manually go in and change properties for one thing 20 different times, so I just scripted it in. But yeah, so I use it a lot for automation. I'm sure other people use it for other things, like if they have more complex models they wanted to put in that isn't as simple, then you can do that. But yeah.
So pretty much what you kind of do on the screen here,
Yeah.
Yeah. Also probably valuable to note that SDK has a number of engines that sit underneath it, and what we're interacting with is just the GUI, the visual interface. But you can also take the engine itself and run the engine to just give you the data. And you can do that by scripting, by coding. And that way you don't have to have all the visuals. I mean, they're nice to look at, but if you really just want the data, there are ways to just do that as well.
Okay, if there's nothing else, thank you for your time. I hope that wasn't too dry and you got some value out of that.
Thank you all.
Thank you.